Hi, let's continue. We'll start with the term variable. We created an integer variable called term_int, which contains the term of the loan in months as an integer number. As you can see, we have only two values, 36 and 60 months. Therefore, there is no need to further split the variable into categories. Let's call the woe-ordered continuous function on it, just as we previously called the woe-discrete function on our discrete variables. This means that our first parameter will be data frame inputs preprocessed. Our second parameter will be the independent variable name term interest, and our third parameter will be data frame targets preprocessed. We can assign the results to the same working data frame, dftemp. Now let's visualize the results by calling the plotByWoe function on dftemp. Okay. It seems 60-month loans are much riskier than the 36-month loans. The only thing we can do is keep two categories, or dummy variables, for the term in the final model, 36 and 60 months. Naturally, the 60-month category will be the reference category. Let's make a note for that in our list with reference categories. It's time to create our dummy variables. We'll name them in a similar manner to the dummies that came from discrete variables, using the convention original variable name : category name. So let's create a new column in data frame inputs preprocessed, named term:36. We want that variable to have a value of 1 for all rows where the term interest variable has a value of 36, and 0 otherwise. A convenient method here is numpy, where. It works in a very similar way to the Excel if function. We have a condition and a value if true, and a value if false. So np where round brackets. Then we should put our condition in another pair of round brackets. Our condition is the term interest variable from the data frame inputs preprocessed equals 36. After our condition, we put a comma and say what value we should be returned if the condition is true. In that case, the value is 1. Then we put another comma followed by the value we should get if the condition is false, that is, 0. And we're done with this dummy variable. In a similar vein, we'll create a dummy variable for a loan term of 60 months. Actually, we can copy the expression above and just change the name of the variable we want to create from term:36 to term:60. Next, we should also change the condition here, because we don't want to get ones where term equals 60 and not 36. And that's it. We've turned this continuous variable into two dummies. It was not as hard, mainly because we only had two outcomes. We did not even need to perform fine classing, nor coarse classing. Sometimes it is that easy. Alright, let's have a look at a more complex case. The feature of interest will be employment length. If you remember, we created a variable called emp_length_int, which contains integer numbers showing employment length in years. It is only 11 levels, the integer numbers from 0 to 10. Therefore, similar to the term variable we've already been through, we don't have to do fine classing. We'll display the results straight away by calling the woe-ordered continuous function on data frame inputs preprocessed the employment length integer variable and data frame targets preprocessed. Great! Now let's visualize the results, executing the plotByWoe function on the data frame with the results. Awesome! Based on how the weight of evidence changes with employment length, we can easily determine the categories for the PD model. There is more than one correct way to bundle them up, but I'll show you the one I would choose. The first category will be borrowers with 0-year employment length. The second category with 1-year employment length. You can see that weight of evidence hardly changes for employment length from 2 to 4 years, so that will be our third category. Okay. Apparently, weight of evidence is much lower for 5 years and almost the same between 5 and 6 years. So in the next category, we can group employment length from 5 to 6 years. Weight of evidence for 7 years is significantly higher compared to that for 6 years. Now, weight of evidence for 8 years is somewhat higher than for 7, but then the value for 9 years is almost equal to the one for 7. So, it is not a bad idea to put employment length from 7 to 9 years in one category. Alternatively, we could create 3 different categories, but normally we prefer fewer dummies. Finally, employment length of 10 years or above most definitely belongs in a separate category, as its weight of evidence is much higher compared to the rest of the categories. Moreover, the number of observations falling into that category is about 1/3 of all observations. To finish the analysis of this variable, we determine the riskiest group. Borrowers with 0 years of employment are riskiest, so 0 will be the reference category for the model. Let's write that down. Good job! Once we have analyzed the variable and made a plan, we can proceed to actually creating the dummies themselves. We can use the NP-WHERE method, just like we did for the term variable. However, this time, the condition we'll check is whether the employment length integer variable is in a certain list of values. When working with lists in Python, it is very useful to employ the isIn method. It returns true if a value is in the list and a value false if it isn't. For example, for the first category, we'll check if the employment length integer is in a list containing only the number 0. Similarly, for the second category, we'll check whether it's in a list containing only the number 1. The third category is from 2 to 4, so here we'll check if the value of the employment length integer is in the range from 2 to 5. You will notice that the range function returns a list of integer values starting from the lower bound included to the upper bound excluded. So here, it will return the list 2, 3, 4, and it won't include the number 5. By creating this variable, we will have performed coarse classing for the first time. Great! Finally, we create dummy variables in a similar manner for the other 3 categories. Alright, this variable is out of the way too. Let's wrap up here and continue with more complicated preprocessing in the next lecture. Thanks for watching.